section 313 is titled, How Many Solutions Are There? We're going to be working on page 12 and 13 in your packet. We're going to do page 13 first after we read through the objective. And it says, by the end of the lesson, you will be able to solve systems of equations using multiple strategies, determine the number of solutions algebraically, and interpret them graphically. You have used many different algebraic and graphical strategies to solve equations with one variable. You have also worked with systems of equations in two variables. In this lesson, you will use your algebraic strategies and graphing tools to determine the number of solutions that various systems of equations have and to determine the meaning of their solutions. All right, so we're going to flip over to page 13 first. And the first question on page 13 is question 46. They want us to consider this system. X squared plus y squared equals 25. You guys should all recognize this as the equation of a circle, right? That circle is going to have a radius of 5. It has a center at 0, 0. So picture in your head a circle, right? And then the second equation is y equals x squared minus 13. Once you see the x squared, you know it's going to be a parabola. And then since it has the minus 13, it's going to be shifted down to 13. Okay? So in your head, think of your coordinate plane, picture a circle, and picture a parabola somewhere on that graph. How many different ways can the circle and the parabola appear on the graph with different amounts of intersections or no intersections, right? So there are a couple of choices. Question A says, how many solutions do you expect this system to have? Explain how you made your prediction. Okay? So there are a couple different options, right? What if it had no intersections? So the circle is right here. The parabola goes around it. Okay? What if it had two intersections? Here's your circle, and only one side of the parabola goes through 2 points on the circle. Okay? Could it have 4 intersections? Got your circle. The parabola is seated just right so that it crosses it 2 and 4 times. Could it even just touch the circle at one spot? What if just the vertex was right at the tip top of the circle? It could have just 1 point of intersection. Could it have 3 points of intersection? All right. So these are some possibilities. And it wants to know how many do you think, what you think is going to happen with this particular circle and this particular parabola. Okay. So guess what we're going to do? We're going to solve this system by graphing. And how many solutions do you see? And was your prediction to part A correct? Okay, so what do you think? How many? Maybe put your guess over here to the side. I think it's going to be none. 1, 2, 4, 20, which would be like kind of an unrealistic guess. But if you go in this range, that's where it's going to be. Okay? All right. So for part B, when you guys get into your groups of 4, you're going to graph the circle, you're going to graph the parabola, and then you're going to show the points of intersection graphically on here, and then you're going to write the points of intersection. You can have up to 4, right? And then when you write the solutions, you're just going to write the what? The x values. So whatever your x values are will be your solutions. All right, any questions on part B? Question number 47, you can skip. Just cross it off and write skip. And then turn backwards to page 12. Okay, for page 12, we're going to do question 45. It says, for each problem, highlight each equation in a different color. Be sure to highlight the graph of that equation in the same color. So there are 4 parts. There's A, B, C, and D. I'm going to do B, part B as in boy, with you. And then in your team, you're going to do A, C, and D. Okay, so the first thing they want you to do is use some highlighters. If your group does not have 2 highlighter colors, I will give you highlighter colors, but I'm guessing that you guys have at least 2 highlighter colors in your group. All right, so for part B, excuse me, I highlighted the first equation yellow, I highlighted the second equation orange, and then when I graphed them, I highlighted each of them their corresponding colors, okay? That way you don't have to write on the graph what the equation is, okay? So this first one has an x squared, so it's clearly the parabola. This second one is linear, so it's clearly that line, okay? That's being solved graphically in this third column. And then in the last column, it says explain how your algebraic solution relates to your graphical solution. So the graphs intersect once at the point 2, 3. They're just going to touch right at the tippy edge. And that means our solution is going to be 2. How did I get that algebraically? Since both of these equations were set equal to y, I took the expression on the right in purple here and set it equal to the expression on the right in purple here. Everything else I did in red. So if you could tell the difference in my color, the only purple is the original 2 set equal to each other. Okay? I had a 1/2, so I fraction busted to get rid of the 1/2. So 2 times 1/2 x squared is x squared. 2 times 1 is 2. Then I multiplied this side times 2. 2 times 2x is 4x. 2 times -1 is -2. Then I made a trinomial out of it, right? My x squared was already on the left, so I moved all of these terms over to the left as well. Subtract the 4x, which gives you the -4x here. Add the 2, to this 2, which gets you 4. And then I factored that trinomial. To get your x squared here, you have x times x. To get your 4, it's just 2 and 2, but then you have to determine the signs, okay? They're both negative because a negative times a negative multiplies to get a positive, but a negative plus a negative combines to get the -4. You'll notice that these are both the same. We have x minus 2 and x minus 2. So you have set it equal to 0. Technically, you do it twice, so you get the same answer twice. That's why we only end up having one solution on this problem. But you could see that if this line went this way, or even slightly tilted, it's going to intersect that parabola twice, right? If it was going straight across, or even slightly slanted a different way, you could have very easily get 2 solutions instead of just 1. All right? So you guys are going to do A, C, and D in your groups, and then finish up the graphing on page 13. And then that's it. All right? You guys can turn your desks into your groups. Oh, Did I tell you guys that the class downstairs wants you to do it as quietly as possible? Or not. I'll come around in just a second and make sure you guys all have highlighters. But if somebody has 2 highlighters, that would be great.